I now want to work through problem number 70 from section 2.3. This problem is titled two-way radio range. So two-way radio range. So let me go ahead and read this problem. We can try and work it out. Two surveyors with two-way radios leave the same point at 9 a.m., one walking due south at 4 miles per hour and the other due west at 3 miles per hour. How long can they communicate with one another if each radio has a maximum range of 2 miles? So basically the idea is here they start walking, they're together, and then one guy starts walking south, and the speed or the rate he's walking is 4 miles per hour. And then the other guy starts walking west, and he walks at 3 miles per hour. And the idea is they can keep in radio range as long as they are less than 2 miles apart. So it's almost like if the distance between them, the farthest they can be apart is 2 miles to be in radio range. So now it's asking, when they start walking, how long can they walk until they lose radio range? Or in another sense, it's how long can they walk until they're more than 2 miles apart? So, this is a problem. It's going to be based off of distance equals rate times time. What I'm going to do is I'm going to use this equation for both of these guys. I'll call it D sub W, which means the man that's walking west. The rate he's walking is 3 miles per hour. And the amount of time he's walked, I don't know how long it takes him walking until they're out of radio range. And the man walking south, I'll call D sub S, he's walking 4 miles an hour. And he also is going to walk a certain amount of time till they're out of radio range. Now, if you think about it, if I draw the picture again, so here's the distance the man walks going west. Here's the distance the man walks going south. And I want to know what's going on when this distance between them is 2 miles. If we think of this as a right triangle, we would say the hypotenuse is 2 miles. As a matter of fact, if we use the Pythagorean formula, it says dw squared plus ds squared equals 2 squared. Remember, for a right triangle, the sum of the squares of the sides is equal to the square of the hypotenuse. So I'm now going to plug in for dw my 3t, so it's 3t squared. And for ds, I plug in 4t. 4t squared equals 4. And now I'm going to have a quadratic equation that I can solve for t. 9t squared plus 16t squared equals 4. Or I could say 25t squared equals 4. And finally, t squared equals 4 over 25. And now if I take the square root of both sides, I get t plus or minus 2 over 5. Of course, you can't have a negative time. So you'd say the time is 2/5 of an hour. Or you could say 24 minutes. All right, so this is a problem where we had to use our distance equals rate times time, but then we had to remember the formula for a right triangle, or the Pythagorean formula.